Welcome back. We're going to look at pandas in Python. To begin, we can have pandas there as the heading. And to use pandas, we'll need to import it as PD and also import numpy as NP. We are going to start with series, which is simply a one-dimensional labeled vector. So we can define a series as follows. So using pd.series, and then you pass a list of numbers, can be positive or negative. You can go ahead and print that out. So we see that we have the values and the index. We can check what the values are and what the indexes are. So we can say object dot, and then you say index. That shows you that the index is 0 all the way to 4 on a step of 1. Remember, the end index is not included. That's why the index is 0 to all the way to 3, including the 3. We can also check the values, what the values are, and we see that the values is basically an array of lists of numbers, and they are of data type integers. And as you have seen, that our index is simply numbers. Those are just automatic. We might choose to change that to some sort of labels. And to do that, we can specify the desired indices that we want to use by simply having a comma and specify our index. And our index are simply a list of string characters, DBAC. So can go ahead and print that out, object 2. If I print it out, we see that now our indices are DBAC, and those are the values. If you decide to say object 2, and then you check the index, you get the same thing. You get the index are now labels, and the values just remain the same. And we might want to select some values from that series. And how to do that? We use indexing. And to use indexing, we say object 2, and then we open a square bracket and we pass the string or the label. So if I execute that, we get it 4. Because our D is, so we are using the index to access the value of 4. And remember that this is, if we, for example, choose to use index 0, we get 4. So basically, we can use either the index numbers, which is 0 to 3, or we can use the labels of those index. So basically, we can either use the number or the label. Also, we can select the values, or maybe we might choose to change a value of a certain value. So what we do, we just use this. We can say, assuming you wanted to change the value of D, index D. So we use the index with the label, and then we assign it to D. If I execute that, we get, now the value of D has been changed to 6. And suppose now we wanted to select using a different way. We can use Boolean expression, and Boolean is simply true or false. So in this case, we can use this greater than, assuming you want to get all the value or to select the values of that series that are greater than 0. So we pass, instead of the index, we use this object 2 is greater than 0. This one we just evaluate whether it's true or false. If it's true, then that going with object 2, then we are going to print out all the numbers that are greater than 0. So we get 6, 7, and 3, because -5 is automatically less than 0. So that's what we get. Also, we can perform some mathematical operations. For example, we might choose to multiply every number that is in that series by 2. So we simply say asterisk 2. That is, any number will be multiplied by 2. So if I execute that, I get 12, 4, 14, negative 10, and 2. Basically, all the numbers have been multiplied by 2. We can do something like division. We can do subtract all the numbers in that series. You subtract 2 from them. You can choose to do a floor division where you don't have the decimals. So you get 3. Notice the difference between these two, a floor division and an actual division. So what's happening here is that this one is the floor. What is happening is that this has been rounded off. So not rounded off, yeah, been rounded off to the nearest 0, to the nearest integer. So that's it. And then you can also decide to check if a certain value is included in a series. And to do that, we use the index, we use the in keyword. And how to do that? We write our index label, then followed by the keyword in, and then our series. This will just evaluate whether it's true or not. Is it in or not? If it's true, if B is contained in that series, then it's gonna evaluate to be true. And if we check something that is not there, if E is not contained, then what happens? We get a false. And you can also convert a dictionary to a series where the key will become the index label, while the values will become the series values. For example, you might have a dictionary called as data with the name of states and some value. So this is the key and the value. I'll go ahead and print out that dictionary. And to convert it to a dictionary, what we do, we simply we use pd.series, and then we pass as data, which is a dictionary, as an argument. So you can go ahead and print that out. Objects 3, you print that out, you get, it's actually a series, a labeled series, where the states are the index labels or the indices. And you can also decide to add values to that series. And how to do that? We simply use, you assign indexing, you assign that to a certain value. If I execute that and print out the value of object 3, we have an additional value for Kansas, 18,000, and that's how to add. What if now you want to delete a value? Delete value. To delete value, we use the delete keyword. And to use the delete keyword, so you simply start with the delete, del, that's the keyword, and then you use the indexing Kansas. So it's object 3, square bracket, and then you pass the label or the value label that you want to delete from that series. So if I click that, I execute that and print out the value of object 3, I get Kansas has been deleted. And we can have another series where we can have a value NA in that. So basically we can simply convert a dictionary called data, which has a none. None simply means it's NA, and we pass that inside the pd.series. So to convert it to a series, we can go ahead actually and print this out, object 4. So basically, as you can see, we have not a number. And if, for example, now we decide to do some addition, to add two series, and we say object 3 plus object 4, we get NaN for Utah and NaN for California. The reason, our object 3, as you remember, had Utah, but our object 4 doesn't have Utah. California is NaN, the value of California is NAN, which means because to add two series, we are adding the corresponding values, specific labels. So if you can't perform any mathematical operations, then it returns NAN. So that's why we are getting that. So how would we be able to get rid of NAN such that if California, the value of California was present, we can assign it a value. If it's absent, it's 0. But for Utah, it's in one series but not in the other one, which means we want to get the actual value of Utah. So what we do, we initialize the value of NAN. So it's like we use fill value. If it's NA, if it's NA, then the value would be 0, will be replaced with 0. So if it's missing, then it's going to be replaced with a 0. So we can do this. We use add function. So we write object4 dot add, and then inside the add function, we pass object3, comma, and then the initial value of NA, or NA, the value that's going to replace NA. So if I execute this, I find out that California will still remain to be NAN, but the value of Utah will be printed out. So the next thing we are going to look at is the data frame. And data frame in Pandas is simply two-dimensional spreadsheet-like structure. So you can go ahead and add a markdown cell or a text file and have it as a header there. And we are going to start with how to create a data frame. So basically, you can have a header there, construction. So you can construct, how to construct it. So here we can simply convert a dictionary with multiple values for each key and convert it to a data frame using data frame keyword. So first we can have the dictionary, which has multiple values for each key, but the number of values have to be the same. And then after that, we can convert that dictionary to a data frame using pd.dataFrame, and you pass data, the dictionary, as your argument. But remember, note this is capitalized. D is capital and F is also a capital. So what is happening here is that the dictionary will be converted to a data frame. We can go ahead and print out the data frame, and there you go. We have a data frame that has 3 columns: state, year, and pop. We believe that pop is population. And as you can see, we have the rows have been given some index. From here onward, we are going to the labels for the rows called indices. So now the next thing we are going to look at under data frames is how to add columns. You can have it as a header there and convert to markdown and then paste that. So, and how to add that, to add columns, is actually very easy. All you need to do is just specify the columns that are already existing, and you include a new column. For example, if we wanted to add a column called deaths in our frame 2 there. So basically what we do, we pass data and then columns, you assign them to a list of string characters. And we know that in data, we have year, state, and pop, but we don't have that. We have index, but it's just index numbers. So here we specify the labels for those index or indices. So if we go ahead and print this out, frame 2, we realize that there's an extra column that has been added with all the values being missing. Not a number, or basically you can say NA. Now, how do we retrieve columns from our data frame. To retrieve columns, we simply use indexing. So, and we simply use indexing with the row index state with a column name. So we are passing the column name inside the square bracket. And here, if I execute that, I get the state column. And remember, our rows are labeled, or they have some labeled indices. And this is one way. You can also use frame2 dot the name of that column. For example, if you wanted to get the value of for the column, to retrieve the column called year from frame2, then all we need to do is say frame2 dot year. And this is it's actually the same as how we would select columns in R programming. So if I execute that, we get the year column. That's how to retrieve columns. And to retrieve rows, it's a bit different. We need to use the indices. So there are two ways. It's either you use the label or you use the indices. So for example, we can choose to use the labels. So we can retrieve rows using the name or the position. Those are two ways of how we can get them. So using the name of that index and this lock, it's called frame.lock. Lock, we use the labels. But so I can go ahead and print that out. So basically I get row 3, which has the values. I can see row 3, which has these values. Also, we might decide to use the indices. For indices, we have to use ilock. For ilock, it's like index location. So we use the ilock with the numbers. So if I print that out, I still get the same thing. Remember, this is row 3 because we always start to count from 0. So it's 0, 1, 2, which means that that's that. So that's why we are getting the same output or the same results. We get the same results. And suppose now we want to reassign some values. To reassign some values, we have to pass a set of numbers. If you have like five rows, then you have to pass 5 values for a certain column. And to do that, for example, we might choose to fill the date column with 5 set of numbers. So we can do this. We can say this one will just select the column date, and we assign it the values using numpy, which is np dot arange and 5 dots. This dot means that the values that we are going to generate here using this are going to be of float type. So if I execute this, we get the values 0, 1, 2, 3, all the way to 4. Remember, we start counting from 0, which means if we pass here 5, it means that we are not going to get to 5. It's going to start from 0 all the way to 4. It doesn't include this value that is inside that has been passed as an argument. So we get those values, and just like that, our column date has been assigned those values. So now, what if now we wanted to insert some sort of values? So instead of having date as just numbers from 0 to, what if we wanted to insert some values to replace those? Another cell, I convert it to markdown, and then we'll have a level 2 heading. So to insert some data in a data frame, all we need to do, we can choose to have a separate series with some values, and then we specify the index. Remember, we have named index here, 1, 2, all the way to 5. we have our columns, and now if we wanted to add column here to change these values, specific values, we can first define a series with how many values? This is 1, 2, and 3. Therefore, we are going to specify for which rows we want to replace the values. So here we want to replace row 2, 4, and 5 with these 3 values here. So to replace that, all we need to do, we are supposed to come and say, we take frame 2, we select our column, date, and then we assign it val, and val is a series with 3 values. And since we have specified the indices we want to replace, then let's see what we get. Frame 2. If we print this out, we find that row 2, 4, and 5 have been, some values have been inserted. And given that we didn't pass values for 1 and 3, those are left to be NaN. Remember, the whole column is being replaced, and we only passed 3, so anything else becomes NaN. Now, what if we wanted to delete some columns? How would we achieve that? We have some columns that you don't need, and you need to delete them. So to achieve that, we have that as a heading. First, we can do some manipulations here. We can add a column called Eastern, and we assign it some values where we are taking frame 2 dot state, so that we are checking if state is equal to Ohio. Do you know what this will evaluate to? If your answer is true or false, you are right. So basically, this will just check if in this column any of these are equal to Ohio. If it's Ohio, then it's going to return true. If it's anything else, it's going to return false. So if I execute this, we see that we have a column that has been added called Eastern, and Eastern has 3 trues for 1, 2, and 3, and false for the rest. Now, suppose now we want to delete column. To delete a column, we use the del keyword in Python, and we pass the column that we want to delete. And to do that, we can use this, that del frame 2, and then we pass Eastern in that square bracket. Remember, this just simply selects a column. So if it comes after del keyword, then it means that it will be deleted. So I can do that and print out frame 2, and just like that, the Eastern column has been deleted. You can check if using this method, print out frame 2 dot column to check the what columns we have, and as you can see, Eastern is not there, so basically it has been deleted. Now that's the way to delete column using the del keyword. So what if now we wanted to delete or to drop some entries, basically rows? Entries are rows in a data frame. So if you wanted to drop some entries, you can have that as a heading. So suppose now we had a series called object, obj. Actually, you can print it out, obj object. So we have a labeled series, and we want to drop some entries. So how to do that? We use the drop function, and so we first call our series, and then we type the word we type dot, and then we use the drop keyword, and then we inside the drop function we specify the label for that index that we want to drop. If I go ahead and type print out new obj, if I print it out, you realize that C has been deleted. So we have A, B, D, E. So that's how to delete an entry from a series. So how can we do it in a data frame? Suppose we had a data frame called data, which takes the values 0 to 15 or 0 to 16, not including 16, basically 0 to 16, and we reshape that to be a 4 by 4 to 4 by 4. So basically you're having 4 rows and 4 columns. And we label our index to be these states: Ohio, Colorado, Utah, and New York. And our columns, we name them 1, 2, 3, and 4. So if I execute this and print it out, I get 4 columns and 4 rows. So now, if you want to drop the entries, there are two ways. Do you want to drop some columns or do you want to drop rows? So to drop rows, then we use data.drop. We can do it this way. So here, call our DataFrame.drop function, and then if you want to drop more than one column, then you pass it as a list. So if I do that and print out data, actually we get 1, 2, 3, 4, and Colorado and Ohio has been deleted or have been dropped. So this is what we get. Now, suppose now you wanted to drop some columns. Here, you have to specify the axis. Remember, in a data frame, the row are considered to be axis 0 and the columns are considered to be axis 1. So, if you wanted to drop the columns, then we have to use the drop function, pass a list of columns that you want to drop, and we specify axis equal 1. So if I execute this, I get our data frame with columns 2 and 4 having been deleted. Hope that is clear. Then the next thing we're going to look at is another way of creating a data frame from a nested dictionary. For a nested dictionary, we can use an example. It's easier to understand using an example, and convert that to Markdown and have it as a header or a heading. So first we can declare a nested dictionary just like that. Here we have Nevada as the key, and then the value is another dictionary. That's why it's called a nested dictionary. So we have year and the value, another year and the value. And then for Ohio, which is the second key, and then inside for the values, we have 2000 and 2001 as a key, as the keys inside that dictionary. So I'll go ahead and print that out. So we see it's just a nested, it's actually a nested dictionary. So suppose now we convert it to a data frame. Let's do that and see what we get. So we just pass it as an argument and print it out. So as you can see what happened there, the keys, the first set of keys becomes the columns, the column names, and the second, the keys in the inside becomes the row labels or the indices. And then inside, now the values becomes now the values of that data frame. Hope that is clear. So there's also something else we want to do. Suppose now you want to label this as our data frame that we've just created to be these two to be states. We want to label them. So we basically want to set row and column names. So to do that, we can have it as a header, convert it to Markdown and execute. And first, we can set the index name using the following. We can say frame3.index.name, and then you specify that. So we have the name of our index or the rows is years, and we can also set the name for our columns. So our columns will be state. And if you go ahead and print out our frame 3 and execute that, we see that we have our states is Nevada and Ohio, and year is 2001, 2002, and 2000. So we can check the value attributes. If we check the value attributes for this one, actually we use frame.values. If I execute this, we see the values is 241.1.7, just like that. The values that are inside here. We can also check the index. The index would be 2001. Now the years, it's of integer 64, and the name has been set to be year. We can also do the same for columns, just to have a feel of what we're dealing with. So it's Nevada and Ohio. Data type is object, and the name has been set to be state. And now, the next thing you're going to look at, it's very crucial for you to understand. Because for you to work with data frames, we need to know how to, we need to know how to join multiple data frames. And to do that, we use join keyword or join. We can use merge and join. But in this case, we'll first look at merge function. That's what we are going to use. Just convert this to markdown and have it as a header. So in SQL, we call it join. So we have left join, outer join. So here we can actually have two sets of data frames. We can have left frame and right frame. It's too much to type, so just copy and paste. So here we have our left frame, which is pd.dataframe. Then we pass a dictionary, and the dictionary is key and takes the value range 5, which is simply 0 to 5, and then another key left value, which takes the value, but the values that it takes is actually string, a list of string. So you can execute that. I can go ahead and print out left frame. So that's the left frame. Can print out the right frame. So you see it's key, right frame has other values. A quick look at this. We see that we have the key is 0 to 4 for the left frame, and for the right frame it's from 2 all the way to 6. Now we are going to look at different types of join. The first one that we are going to look at is the inner join. And inner join, what it does is simply take what is common between the two data frames that you want to join. And we use the function merge, and this is how it will look like. Merge usually take some few arguments. It takes the left frame, the right frame, and we also specify the on what. How do you want to join those data frames? What is the primary key? We call it primary key in SQL, but here we simply use it as the key. What is common? What is the unique labels that you want to use? In this case is the key. And we also need to specify how. And here is where you're supposed to specify how you want to join them. So in this case, we are using inner join. So if I execute that, we get key. What is common between them is 2, 3, and 4. And then the left value is C, D, and E, and the right value is F, G, H. So basically, it came here, took the value, this column, and added another column there, and only took a set of what is common using the key. The next one we are going to look at, it's the left outer join. So basically, what it does, it just take the left frame and then join it with all the matching values based on the key from the right frame. And go ahead and do that. So basically you're getting, using the how is equal to left, and the joining column is the key. So basically, you're getting key, left values, everything in the left frame will be present, and then anything that matches from the right frame is gonna be passed on to, added on that column, and anything that is missing is gonna be NaN. The next thing you're going to look at is the right outer join. So here, everything on the right will be included, and anything that matches from the left frame will also be added as a column. And if it's missing, then it's gonna be NaN. And we have something else we call full outer join. And full outer join, this one will include both everything from the left and everything from the right frame. And anything that matches is gonna be included in both. But if it's missing from the right, it's gonna be on the right value. Then if no matching key from the left, is gonna be NaN, and on the left value column, if it's missing from the right frame, then you're gonna have NaN. And then the next crucial thing you're going to look at is how to combine data frames. So here we use what we call concat. Basically, we are trying to concatenate data frames. You can have a markdown cell, execute. So the default is that the objects are vertically appended. If you use the concat function and you pass a list of left frame and right frame, then all it does is just append the values. For example, you can have a comment explaining that, and we can pass a list of data frames inside the as an argument in the concat function. So if I execute this, this is what we get. So first we'll have our left frame on top, and everything else from the right will be included. And for the key, for anything that is matching between the two, then those will be merged, or will be concatenated in one column, and the unique columns in the two frames will be added as separate columns in the concatenated frame. Now, if we want to specify how we want to join, we add a comma and then axis. We specify the axis, how we want to join, how we want to combine them. So if we specify axis and we say axis 0, meaning that it's by rows, we see that it's simply like using the default one. So basically it's just the same as what we got here. But then now what would happen in case we change the axis to be 1? It's gonna add them as horizontally. It's gonna add them horizontally or combine them horizontally. It's gonna take the left one and the right one and append them horizontally. And that's how we have that. That's what we get.